Guys, thanks for watching this video. I just wanted to do a couple problems to help prepare you for the exam because I'm not sure if we covered them in the videos well enough, and maybe the notation was a little bit confusing. So I hope that you find this video helpful, and please, well, if you're already watching it, that's great. Okay, so let's get to the problems. All right. There's some important concepts that I want to make sure that everybody understands. And um, remember, you get 4 attempts to do the exam. So if it didn't go well the first time, that's okay. It's going to take the highest grade. So if something didn't go well, just I will try and give you feedback, and then we can go from there. Okay, so make sure you look at the equations, and I will try and give you feedback. But I want to cover a couple of things in this video. So let's get to it. All right. So there are a bunch of projectile motion problems where um, it's it's going to ask you to basically, all right, here's a problem. Let's say that you have, and this is going to be a little bit different than the one on the exam, but the process is going to be pretty much identical. Okay. So let's say that we have an airplane. Okay. And the airplane is flying horizontally. Okay. So it is going this direction. Okay. And this could be, we'll say that this has an initial velocity of maybe, let's do 80 meters per second. Okay. And I want to do this problem because it is a projectile motion problem, and it illustrates that you need to solve X and Y equations separately. Okay. And let's say that this airplane is 300 meters off of the ground. Okay. So we'll say this is 300 meters. Hey, that's how high the airplane is. All right. And let's say that the airplane releases a package, okay? And the package initially has the same velocity as the airplane, which is 80 meters per second, and that is all in the X direction, okay? Now, how do you solve this problem? Because if I ask, well, how far does the package travel before it hits the ground? Well, first of all, the package, it's going to fall something like this. Okay. So it's going to fall down. And the way that you go about this problem, there's 2 steps. Okay. So first, you have to solve the Y problem. Okay. And the Y problem is easy because it's just basically, all right, we have my package up here, and initially, its y velocity is 0, okay? Because it's traveling completely horizontally, so its initial y velocity is 0. Okay, so we need to figure out how long does it take the package to fall to the bottom. Okay, so all I would do for step one is I would say how long does it take to fall 300 meters? And the equation that I would use, it would be y y final minus y initial, okay, plus v iy times t, and then minus 1/2 gt squared. Okay. All right. Well, I'm going to call down here, this is going to be y equals 0. And so my final y position is going to be YF equals 0. Okay. And Y initial equals 300 meters because it starts up here. Okay. And my initial Y velocity is 0. Okay. So this term is going to go away. Okay. So this term cancels. This one goes away too. It's just equal to 0. Okay. So now I have this one here. It's yi, and I bring it to the other side, so it's a negative over here, equals minus 1 half gt squared. Now, since these are both negative, okay, I can multiply both sides by -1, and that will change it to positive. Okay, since they're both negative, that's fine. Okay. All right. So now we can solve for t by getting everything on the other side. So I will multiply both sides by 2. So times 2 over here, and then I'll multiply by 2 over here. Um, so these ones cancel. Then I'm going to divide both sides by g. Okay. This g goes away. And so now I have t squared equals 2yi times divided by g. Okay. And so now I'm going to take the square root of both sides. Okay. I'll take the square root of that one and that one. And so now I get t is going to equal, because t squared, if I take the square root of that, is t. I'll have 2 times 300 meters divided by 9.8 meters per second squared. Okay. And this is part one. And this is going to give me the time here. Oh, and this should be in the square root. Don't forget that square root. Oh, okay. Now, if you wanted to, let's yeah, I'm gonna go throw this in MATLAB real quick. All right. I think I got MATLAB is open, and I'm gonna share. Okay, so I'm gonna share my screen here. So I'm gonna say this, the square root of 2 times 300 divided by 9.8. Okay, that gives me 7.8246 seconds. Okay, that's how long it's going to take the package to fall down here. I'm gonna make this bigger. There we go. Okay. So I'm going to write that down on my card here. So T is going to equal 7.8246 seconds. Okay. Now, some of you have expressed concern. You're like, there are a lot of equations in Pearson, and how do I know which equation to use for the problem? Okay, well, let's go back to your card here, and you want to look at the kinematic equations. Okay, my 5 kinematic equations. Definitely, you're going to need to know these for the exam. Okay, and in this problem, you need to solve for time. Okay. And so this one has time and also has distance. And so I'm going to use this equation. Let me write that one down again over here because, oh, I actually already wrote it here. Okay. So that was one of my kinematic equations. I picked this one because I'm trying to solve, I know y here and I'm just solving for t. Okay. So that's why I picked that one because I need to have the distance in there, right? You need to have the distance in there to solve for that one. Okay. Now, um, let's talk about each of the equations and why or why not you should use them. Okay. Well, and I'll write them down again here just so we can have them. Okay, so equation one, delta x equals v times delta t. Okay. Now, if I'm solving for um a in y, this equation is not good because there's no acceleration. Okay, so that's not going to work in the y direction because in the y direction, you need to have acceleration, okay, if it's falling. Now, this will work for x, and in fact, this is the equation that we're going to use for the second part, okay? But we'll get to that in a minute, okay? So here, this other one, delta V equals A times delta T, okay? Now, this one is good, but it doesn't take into account the distance, okay? It just tells you how long did it take to change velocities? Okay, so let's say you were mm, maybe ice skating or something, and you hit a rough patch, okay, and you slow down, and it takes a certain number of seconds to slow down. Okay, you could calculate what was the acceleration of that. Okay, so definitely know how to use these and when to use them. Let's look at the other one here, three. Okay, and this one is x of f equals xi plus your initial velocity times t um plus yeah, that's supposed to be t, 1/2 at squared. And remember that x here could be y, right? It works in both x and y. And your acceleration could be negative. You know, if this is in the y direction, then a is going to equal negative g. Okay. And okay, so then that's the third equation. The fourth equation is VF um, equals VI plus A times delta t, okay? And then my last equation finally, F, yeah, VF squared equals VI VI squared. Don't forget that these are squared. That is really important. And if you forget that square, your answer will be way off, okay? And then this is 2 times the acceleration times x, okay? Now, this last equation does not have time, and so uh, it would not work for this equation, okay? This would be for a problem that you don't know what the time is and you don't necessarily need it, okay? So, and remember that the more you do problems, the easier it becomes. It's just like everything, right? And it's the first time that pretty much anybody takes physics, right? Um, the first time you take physics, right? Um, it's not easy to know. I remember when I took it, that was like many, many years ago, but it's hard to know which equations to use. And just by doing more problems, you get better at it until you start to realize, okay, here's what I need to do. So, if you don't get it right the first time, don't feel bad at all, okay? There's nothing to feel bad about. Um, the important thing is that you keep trying and you figure it out eventually. My philosophy is, if you take the exam, you get a bad score, you can retake it. I think there's 4 tries on there. So, just go back and fix your score. And I'll try and give you feedback so you know what happened. Okay. But let's get back to this problem because this is really important for the exam. Okay. Now, I know that this is about an airplane, but it could also be about an object launched from a certain height. Okay. It really doesn't matter. Let me re-emphasize that. Okay. So, in our problem here, I talk about that this is an airplane, but it could be for something launched off of a building or, any projectile that starts at this height that has an initial velocity will work. This method is going to work for that. Okay. So now that we have the time here, the last part is we need to calculate this x distance. Okay, what is the distance that this thing travels? Now, for this part, for part two, this is going to be part two. Okay, so I'm going to write this in with a different color ink. Okay, so part two, right? You need to understand that in part two, there's no acceleration in the x direction, right? Once it's going, it maintains that constant velocity. And so we want to use equation two for this one, okay? Because right here we have, oh no, sorry, I said, oh man, equation one. Oh geez, Dr. Wisby. Okay, so I'm trying to find x. This is what I want to know. I know what VI is. It tells me in the problem. VI is 80 meters per second. Okay. And I know what T is now. Okay. So I just solved for T. So I'm going to use delta X here. equals V times delta T. Okay. Okay. So once I know the time, I can just plug the numbers in here. Okay. Delta X is going to equal 80 meters per second times the time that I calculated here. And I'm going to keep all those digits, right? I'm not going to throw those digits away until the very end. Okay. So this will be 7.8246 seconds. Okay. So I'm going to go throw that into, I'm going to throw it in MATLAB. All right. So we have 80 meters per second times 7.8246, and it was just right above there. Okay. So the answer is that it will travel 625 meters. Okay, so what do I get for the answer here? All right, it's going to travel, the distance here is going to be 625.9680 meters, and that's too many digits, so you're gonna need to round this off to 630 meters. Okay, so that was it. And if you, yes. This will help you on the exam, and this is also useful for many, many projectile motion problems. Okay, so thanks for watching this video, and please, if you need to get help, I'm available on Zoom most of the time. All I'm doing right now is basically just teaching this class. I go into my lab a couple hours a day, like from 1 to 3. But other than that, I can meet with you basically anytime. Okay? So please schedule a Zoom appointment. Let's do some problems together. Or send me requests for videos and I'll do problems and put them on YouTube. Thanks for watching. Like and
Thank you. Like and subscribe down below.
thanks.